All right, let's jump right in. Have you ever thought about this? What if an agreement could just enforce itself? No lawyers, no courts, nothing. Well, today we're going to explain the technology that actually makes this possible. We're talking about smart contracts.
So let's really start with that big question. Just imagine a contract that doesn't need a legal team or a courtroom to back it up. An agreement that automatically, and I mean automatically, guarantees that everyone holds up their end of the bargain. That's the core idea we're going to unpack today.
Okay, so first things first. Before we go any further, we really need a clear definition. What exactly is a smart contract?
What's really interesting is that this isn't some brand new idea. The concept was actually formalized way back in 1996. The vision was a world where agreements were literally embedded directly into computer code, making them incredibly difficult and very expensive to break.
So the key difference really comes down to the enforcer. A traditional contract, it relies on human intermediaries, right? Lawyers, judges, maybe bankers, all people who interpret and enforce the terms. But a smart contract, it replaces all of them with code. It lives on a blockchain, which is basically a decentralized and unchangeable public database. And that blockchain acts as the automatic, totally impartial enforcer for the entire agreement.
So you might be asking, why go through all this trouble of turning contracts into code? Well, the answer is that it solves a really fundamental challenge in almost every single transaction we make.
The whole reason we even need them is to solve something called the trust problem. And this is a challenge that's hiding in plain sight in pretty much every exchange of value that we're a part of.
At its heart, the trust problem is actually pretty simple. How do two parties make a deal when they don't fully trust each other? How can you be absolutely sure you'll get what you paid for, and how can I be sure I'll get paid with absolutely zero chance of anyone getting deceived? For centuries, our solution has always been the trusted third party. Think about using a credit card. You don't actually pay the store directly. You pay your bank, and then your bank pays the store. The bank is that intermediary that both you and the store trust to handle the transaction fairly.
Smart contracts, though, they offer a completely different model. Instead of relying on one single central party, the transaction gets broadcast to an entire network of computers. This network, the blockchain, acts like a collective witness. It verifies that the terms of the deal are met, and only then is the transaction approved. Trust isn't placed in a single company, it's created through the consensus of the whole network.
Okay, so we know what they are and why they exist. But how do they actually work? What are the real building blocks of a smart contract?
Now this is where it gets really interesting, especially if you have any background with relational databases. The core structure of a smart contract is probably going to feel surprisingly familiar to you, so let's break down the components. A smart contract basically has four main parts. First, you've got data structures. Honestly, just think of these like your classic database tables. They store the state of the agreement. Second, functions. You can think of these as stored procedures, but with a major twist. They are immutable. Once they're set, they can't be changed. These functions define all the possible actions, like transfer ownership. Third, you have events, which act as a public transaction log, creating this permanent, verifiable record of every single action taken. And finally, of course, all of this is written in code. Now that we've got the mechanics down, let's talk about the payoff. What are the real-world advantages of automating our agreements in this way? The core idea of an automated agreement is surprisingly old. The very first vending machine from the first century was essentially a basic mechanical contract. You insert a coin, you receive holy water. Simple. That concept was then formalized for the digital world in 1996, and today, platforms like Ethereum have turned that theory into a global reality.
And this whole evolution brings four huge benefits. You get certainty, because code removes all that fuzzy human ambiguity. You get security, since cryptography makes the contract basically tamper-proof. You get resilience, because a decentralized network has no single point of failure for someone to attack. And finally, you get lower costs, because you're not paying fees to all those middlemen anymore.
This all sounds really powerful in theory, but how does it actually work in practice? How do developers build and deploy a smart contract right now? Right now, the dominant ecosystem for smart contracts, by a long shot, is Ethereum. And the language of choice for building on that platform is called Solidity. Solidity is really the bridge that connects a legal agreement to a digital one. It's the language developers use to translate all the specific terms, conditions, and rules of a contract into code that the Ethereum network can understand and, more importantly, automatically execute. And this all brings us to our final,
Pretty thought-provoking question. We're moving from a world where law is written on paper to a world where law could literally be code. As this technology gets more mature, could these self-enforcing digital agreements become the new standard for how we do business, finance, and maybe even governance?
And that's our look at smart contracts. If you found this explanation useful, do us a favor and like, share, and subscribe for more explainers where we break down complex topics just like this. Thanks for watching.